So today we're going to talk about how we can organize data and how we can look at the shape and the distribution of data. So we already defined this word distribution, but help me out. Remember what we wrote down for distribution. You can just tell me. Just tell me, Tyler.
The shape and spread of data.
The shape and spread of data, okay? The shape and spread of data. Now, some of you on last night's homework, you said, I wasn't totally sure what this question is asking. Well, I'm going to give you some really great vocabulary words that we can use to describe the shape and spread of data. We're going to start by looking at this line plot right here that is hours of exercise per week for students. Okay? Whenever I look at a line plot, the first thing I like to do is to look at the title so I can figure out what is this asking me to look at. Okay? Then the next thing I like to think about is how many people were surveyed. Okay? So we can count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This has data from 15 people. Each one of those circles represents a person. So let's talk about some of the words that we used in our warm-up today. And I'd like to start by identifying the minimum and the maximum. Tyler, what is our minimum?
0.
0. Yeah, that's our minimum. That is our smallest value. Now, just so you know, sometimes kids they'll say that like, oh, it's 0 and 3 and 9 because they each have 1 on them. But that would be inaccurate. Our minimum is the least value, the smallest value here. This is the person that only exercised 1 hour. Oh no, 0 hours. Magnus, what is our maximum?
I do like 6 hours.
That's not our maximum. That's our mode. What is our greatest value? What is the most number of hours that somebody exercises?
4.
No, look at our line plot. If we go all the way over here,
Oh.
what do you think?
9.
9. This is our maximum. Okay, please mark this on your sheet as well. So when you look back at it, you have awesome notes. Okay, we've identified the minimum and the maximum. Yeah.
How come if it's 9, then how come there's 10?
How come there's 10 there? I think that this one, we wanted to be able to easily compare. That's a great question. Easily compare our 2 line plots. And so we made the scales on both of them the same. We don't have to go to 9, or all the way to 10, but they chose to. Okay. Good question. All right, the next thing we're going to find is our range, and that's a new thing that we just learned with our warm-up. So our range talks about the spread of our data, how spread out our data is. And the range is the difference between our maximum, which I'll abbreviate as max, and our minimum, which I'll abbreviate as min. Okay? Now our maximum, our greatest value here, you guys told me was 9. And our smallest value, you guys told me was 0. So we have a range of 9. That describes how spread out our data is. And look, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So our data has a range of 9. Okay, the next thing that I want to look at is our mode. And remember, that's the one that is most frequent. And Kyler, it's awesome that I chose yours because you just gave us a great definition of mode earlier.
So mode?
Mm-hmm.
Okay, so mode for
We're looking for the one that occurs most frequently.
Oh.
It has the most number of people on it.
Oh. 6, right?
6 has 2 people.
Or I mean 5.
5 has 1, 2, 3, 4, 5, 6 people. Is that the most number of people?
Yeah. Yes.
Yeah, it is. So let's also note this is our mode. We had the most people when they were surveyed, and we decided to graph their data. The most common number of hours that students exercised was 5 hours. Okay, now I want to look at clusters and gaps with you guys. Gaps describe space in between data points, and that's important that it's in between data points. So we have a gap from 1 to 2, and we have another gap from 7 to 8. And once again, that describes places in between data where there is no data present. And the next thing I want to talk to you about, the last thing I want to talk to you about is a cluster. So we have this grouping here of data points. So we have a cluster or a grouping of data. Let's go ahead and make some statements to describe any clusters or gaps we might see. So the first thing I want to talk about are gaps. I'm going to say there are gaps from, I'm going to start with this first one over here, from 1 to 2 hours, and another from 7 to 8. So 7 to 8 hours. Now let's talk about our cluster, where we have a grouping of data. There is a cluster from, is that 3 to 6?
Yeah.
3 to 6 hours. All right, I'm going to give you guys a couple of minutes to independently label and examine the hours of exercising per week for coaches, and then we'll come back together. Okay. Tatum, tell us something about this piece of data, or this line plot.
There are gaps
Okay.
from 2 to 3 hours,
Okay. Gaps from 2 to 3 hours.
for 5 hours,
Okay.
for 7 hours,
Okay.
and for 9 hours.
Yeah, so we have these spots without data in between other pieces of data. So we have several gaps. Thanks, Tatum. Okay. Ryan, tell us something that you noticed about this line plot.
Clusters.
There aren't really any clusters here. I agree with you.
Unless if you count the 0.
Yeah, maybe from 0 to 1, but I would look for more pieces of data, and like maybe if it was along 0, 1, and 2, but I don't really think there's any clusters there either. Seamus, tell us something that you observed.
I looked and I observed was that from 0 to 10 there was 10 in range.
The range is 10. All right, if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, we can also do the range is the maximum, which is 10, minus the minimum, which is 0, and we would get 10 for our range. We could do that as well. All right, Finn, tell us something that you observed.
8 hours a week is the mode.
8 hours a week is the mode. You got it. We have 8 hours a week is it is the most frequent number of hours that coaches exercise. Michaela, tell us something you observed.
I observed that 0 was the minimum and 10 was the maximum.
0 is the minimum. I'm going to say min. And 10 is the maximum. Fantastic. And Rhea, will you just tell us what you wrote for describe any clusters or gaps?
What I wrote for gaps was that there are gaps from 2 to 3.
Hold on, there are gaps. Thank you for being patient. From 2 to 3.
5, 7, and 9.
And can I add hours there?
Yeah.
Okay, did you say anything about the clusters?
No, not yet.
Okay. Can we go back to, we'll go back to what Ryan said and say there are no clusters. Let's move down on our note catcher and let's talk about distributions. So how we can look at how our data is organized and how it's spread. So the first type of distribution that I want to look at is a symmetric distribution. And you can think back to when you were little. Did you ever do those paintings where you put paint in it and then you would fold your piece of paper and then you would unfold it? You had the same thing on both sides, right? And that was symmetric. So a symmetric distribution is something, I'll draw a picture of it here, where we have roughly the same patterns on both sides. So if you want to sketch this with me, we could draw a line down the middle where we could like think about folding it in half, and that would be symmetric. Okay, notice I put this extra little X there. It doesn't have to be perfect, but it's pretty symmetric there. The next distribution we're going to look at is skewed left. And this is when you have data where it's more bunched on the right side and is skewed in one direction. And in this case, it's skewed on the left side. So if we think about this being like, we'll put one more here. If we think about this being like, we trace it, and we think of it looking like a little mouse, okay? The skew is going to describe where its tail is. That looks more like a seal, but it's pretend it's a mouse. Okay, where its tail is, and that'll help you figure out if it's skewed left or skewed right. So then skewed right is kind of the same thing, but it's skewed the other direction. Okay, so we'll draw our little mouse again, our mouse seal looking thing. And the skew talks about where the tail is. So let's look at our line plot of hours of exercising per week for students. And I want you to think to yourself, do we have a symmetric distribution? Do we have a skewed left distribution? Or do we have a skewed right distribution? Okay, we're looking at the hours of week for students. Do you have a question? Yeah, what's your question?
Does it have to be perfectly symmetrical?
Good question.
Symmetric distribution?
No. Kind of like our picture down here, because we have this extra 0, or extra X is not perfect, but it's pretty close. Do you have a question? What do you guys think with the raised hand? What do you think? Megan, what do you think?
I think it's symmetric distribution because there's on the left side there's basically the same, except for on the right side it's 6.
Yeah, if we were to fold this in half, right about here. Oops, I'm going to do that one in the middle. If we were to fold that in half right there, it would be symmetric. Now, I would describe this one for coaches as non-uniform. Because it's not any of our examples. So we could call this one non-uniform. Okay. Because it doesn't really fit any of the distributions that we were looking at. All right, crew, your note catchers look phenomenal. Hang on to those because you just got some amazing vocabulary. Good job. We also have a short video that we're going to include as part of our class video.
Shauna, can I show you my project? I want to run it by you before I present it to the class.
Sure. What's it about?
I was supposed to find out how many texts my friends typically send each day. I figured I'd base it on the number of texts my friends sent yesterday.
Tell me about your set of data.
This line plot shows the responses of 15 of my friends.
Some of the values are really different. There's a minimum of 8.
And a maximum of 43.
3 people typically send 28 texts per day. And 3 people typically send 20 texts per day.
What do we call that value? You can just tell me. The mode. This has 2 modes, and that's okay. We can have 3 modes. We have lots of modes.
Those are the most frequent values.
It's funny, the data aren't evenly distributed.
How would you describe this distribution?
Symmetrical.
Symmetrical. Symmetric.
There are big gaps with no data on the line plot.
If there were more data, those gaps might fill in. Or they might not. Look at how the data cluster in certain spots.
I noticed that too.
Have you identified which data value is the middle value?
The value in the middle of the data, it's 22.
This is really good, Nick. You found a lot of things to report. Did your project turn out the way you wanted?
I'm not sure. My project was supposed to explain what's typical. How do I decide what's typical?
Don't worry, Nick. We'll help you. All right.